In Chapter 4, we get to talk about probability and the counting rules. We'll talk about the difference between classical and an empirical probability, talk about probability of an event and compound events. We'll talk about multiplication and addition rules, as well as some counting rules. So the probability is the chance that something happens. So most often, you've probably heard in the past, I have a bag of marbles. I have a bag of 16 marbles. I put 8 red and 8 blue. What's the chance that I get a blue out if I shake them up and draw it out looking? So that is 8 out of 16, which is 1/2. Right? There's half of them are blue and half of them are red. So the probability is just a chance of something happening, and that something is called an event. When that something happens, let's say I pull out a blue ball from that bag instead of a red ball, those are outcomes. If I pull out a red ball, then that's an outcome. The total number of items in that bag, or the total of outcomes that I can have, is called a sample space. A lot of times people talk about rolling a fair-sided dice. So the sample space of one dice is the numbers 1 through 6. Those are all of the possible outcomes I can get from rolling a dice. Let's say that I rolled a dice and I got a 3. The probability of rolling that dice was 1 out of 6, because there's 1 3 out of 6 total outcomes. In this example right here, we have 2 dice being rolled. So the 1 through 6, the outcomes for each dice are recorded on the sides, and then the sample space is all the possible ways that you can roll 2 dice. So there are 36 possible outcomes when rolling 2 dice. One way to record or to find all of these possible outcomes is by doing a table like you saw before. Another way is to use a tree diagram, which is what you see here. In this tree diagram, we have all of the possible outcomes for the order of 3 children in a family. So the first child outcomes, you can have a boy or a girl. Sorry, I'm trying to get a marker here. There we go. So here are your first 2 options. This is our first branch on our tree. This is the first child. You can have a male or a female. But then that doesn't change your second child. Your second child, you still have 2 options, male or female. So let's say your first child was a boy, then your second child was a boy. That's what this information says. Then your third child could also be a boy, and that would give us MMM for male, male, male in that order. But let's say your third child was a girl, then you'd have the outcome male, male, female. Do you see where this information is coming from? So all of the possible second child outcomes are in this second column, and all of your possible third child outcomes are in this third column. And then our total sample space, let me get out of the way here. Our total sample space can be found by writing all the possible outcomes together on the right-hand side. And then what we do is we put them in what's called set notation. So that is a brace. I'm just all in the way. Here we go. That's a brace, and then you list every possible outcome with a comma, and then you close it off with a brace. So if I were doing this again for my fair dice, 1 through 6, I would just have a 1 through 6 with commas in between. Okay, let's talk about what an event is. Again, an event is something that you're trying to find when you're running an experiment. So far, when you're talking about the sample size, this information and this information on our tables here are theoretical probabilities. This will happen theoretically. Or classical probabilities, right? So we can have different outcomes, but once you start to run experiments for that, you get into experimental probability or empirical probability. And I have a slide for that in just a second. But let's talk about some different types of events that you can look for, that you can see. The first event is called I should have fixed this, sorry. The first event is called a simple event. So let's say you're rolling a dice and you're trying to decide the probability of rolling a 2. That is the event. You rolled a 2. But let's say that you rolled a 2 and an even number is showing. So those are two different outcomes. Let's say we roll the dice more than once. It's an even number and it's a 7, or it's an even number and it's a 3. I'm sorry, I can't think of even numbers. A 2. These are compound events when you're starting to look for multiple things when you're doing your experiments. That'll make more sense in just a minute. Okay, so here's the idea of what I'm talking about. The probability of an event is the number of outcomes in the event over the total sample space. So let's look at our dice again. We have one dice, and let's say our outcome or our event is that I rolled an even number. My possible outcomes for rolling an even number are 2, 4, and 6. So I would have a 3 in the numerator. There are 3 possible even numbers. And the total number of outcomes in my sample space are the numbers 1 through 6. So it would be 3 out of 6. So the probability of rolling an even number is 1/2. Same for the odd number. Probability of rolling an odd number is still 3 odd numbers out of 6. Let's talk about flipping a coin, a fair unweighted coin. It has 2 outcomes, heads and tails. So if I flip the coin, the probability of getting heads is 1 out of 2. So 1 heads out of 2 total outcomes. So the probability of getting heads when flipping a coin is 50-50. Now again, this is theoretical probability. The world starts to change when you actually run the numbers here. So be careful. In this little picture I have at the bottom is the sample space for a deck of cards. So there are 52 cards in a deck. There are 13 cards in each suit, so 4 suits, which is hearts, clovers, spades, and diamonds. And there's 1 of each number in each suit, so you can have 4 2s. So the probability of pulling a jack out of a deck of cards, there are 4 jacks out of the total 52 cards, and then you reduce that to 1 out of 13. So the probability of fanning out a deck of cards and pulling a jack is 1 out of 13. You can do the same thing. What's the probability of getting a suit that is a heart? There are 13 out of 52, so that's 1 out of 13 probability. 1 out of 4 probability, of getting a heart. Maybe. Okay, so let's go back to our example that we used our tree diagram for. The family has 3 children. There are exactly 8 possible outcomes. So you can have 3 boys, 3 girls, or any order in between. Notice that we're really focusing on the fact that order matters for this. Each one of these outcomes is equally likely. Whew. You have a 1/8 chance probability of getting either one of these 8 possible outcomes. So the event, exactly 2 of the children are girls, consists of 3 outcomes. So you're looking for 2 G's in your sample set. And there are 3 times that happens. You can have 2 girls in a row, either before your boy or after your boy, or you can have a boy in the middle of your girls. The probability of this event that 2 of the children are girls is 3 out of 8. So 0.375. And notice that when we're talking about probability, you can use a fraction or you can use a decimal. when you're using a decimal, you use 3 spaces after the decimal. That's 3 significant figures. So there's some more rules that probability goes by. All probability is in between 0 and 1, because again, you can use fractions or percentages, so you're counting up to 100% likely. If you have a probability of 0, that means your event cannot occur. It is impossible. But if you have an event that is a 1 or 100%, then it is certainly going to happen. So for example, here in this table right here, we have all the outcomes of rolling one fair-sided dice. So you have the outcomes 1 through 6. Each one has a probability of 1/6 of happening, because there's 1 on each dice. So when you add all of that up, you get that there are 6 out of 6 or 100% of the outcomes. So it has to be between 0 and 1. Let's talk about a complement. So an event is something, the chance of something happening, right? A complement is the sample space that is not in the event. Sometimes it's denoted with this E bar right here. Sometimes it's denoted E prime. Our book uses E bar, so we'll use E bar. Now, so what I'm saying here is that you can have, let's look at our dice again. We want our event to be an even number. So again, we have the numbers 2, 4, and 6. Well, the complement of our event is an odd number, which is 1, 3, 5. So when I add up that 1/2 probability with my 1/2 probability for my event, it becomes 1. So a complement and an event add up to be 1. Now you'll see that becomes useful because we can manipulate the formula as we do right here. So let's look at this example. We have the same outcomes or same sample set of our 3 children as we have before. So the event this time is at least one of the children is a girl. So that means there's 1 G in our outcome. The probability of that is 7 out of 8 of the outcomes have a girl in it. The complement of this is at least one, the complement of at least 1 is none or all. So we're looking for groups that have no girls, or the group is all boys. That happens 1 time, giving us a probability of 1 out of 8, or 0.125. So in this case, the event, is at least one of the children is a girl, and E prime or E bar is all of the children are boys. So we could have, instead of finding the outcomes that were all boys, we could have said we know 7 of them have 1/8 to be all boys. Okay, so here's our definition for empirical or experimental probability. So instead of assuming all outcomes are likely, we're actually going to run an experiment and determine what the outcome actually is. So let's say we have an example here. Instead of assuming that a coin is equally likely to come up heads or tails, so instead of saying there's a 50-50 chance, we're going to take a coin and we're going to flip it 1,000 times and we're going to tally up how many times it comes up heads and how many times it comes up tails. So let's say we've done this. So 543 of these tosses are heads and 457 are tails. So we've run an experiment and this is what we have. Okay, we can divide the frequency of each outcome by the sum of the total frequencies, and that will be our probability. So we can take, for the probability of heads, we have that there were 543 heads divided by 1,000, giving us 0.543. And the probability of tails is that 457 divided by 1,000, giving us 0.457. So this is an experimental or an empirical probability. notice that it's not exactly 50-50, right? So theoretically, we said